Hello, this is our fifth video in the series, and in this video we will talk about UDP client. The same logic as it was explained in the TCP client guides us here. So in this video we will have two microcontroller boards with ESP32. On one microcontroller we will install UDP Server, which was explained in our previous video, and in this video we will install a UDP client on the other board. All the program is written in the ESP IDF 5.0, and the connection will be via Wi-Fi connection. After establishing a UDP socket, we will send the POST request, and we will expect the server will reply to this POST request and echo, and will send the same message back to the client. And in this way we will show the UDP client implementation. Regarding our sources, we have the same page that we talked in the previous videos. Actually, the same page that we have used in all this video series of 5 videos, where we are using the lightweight TCP/IP stack, and we are going through those examples, where our main purpose is to simplify as much as we can in order for them to be understandable in the most simple way. Of course, those examples are more complicated and show you how you can connect in the IP4 and IP6. Here where you will use only IP4, how you can use different options in this. Our video is much more simpler. The example that we are started from was UDP client, and here you see the implementation of UDP client. Our simplified version for this is inside SIMS IoT devices, repositories, socket. And now we are talking regarding the fifth video in the series, which is UDP Socket client. So we will take UDP Socket client file and paste it into our project and compile. But in order to check this file, first we will install a server on our ESP board. So inside VS Code we installed project 5, which is UDP socket client, and inside project 4 we will install the UDP socket server. So we connected our USB port to the ESP board, and now installing a server. Like in the previous video, it's important to take from this installation a board name, so that we will be able to find its IP on the net, because the IP addresses are dynamically allocated. The port we can define here in the software is 333 in our case. As you can see, the IP address that were given by the system is 160 at the end. So we will take an advanced IP scanner and find the name of the board, and in this case it's expressive-2.LAN. Let's copy the name. Okay. Now we can move forward to the installation of the client. Our client is in side project 5. So I will disconnect this board, make sure that the ground and the voltage are connected, so two boards will have the proper power. Okay, now both of them connected. And when I mean connected, I mean this way. I connected those two lines, okay, ground and power. And now I'm connecting the USB port to the second board. Okay. Now we're talking about this one. Now let's install it. Let's have an assumption that this is our address, but it can be changed here. You see, it can be changed. Okay, let's install. Oh, sorry. Okay, now it will try to look for this port, but after installation this can be changed because I disconnected the power from both of those connectors in order to install the other board. Okay, this is an IP of our client here. Okay, and here in this case it's actually worked, but I will show you in any case if it will not work, we can paste the name of our server and we can see the real IP. In our case it's the same IP, but it could be changed, for which was allocated in this power connection. Okay, anyway, now we have a client working. You can see UDP Socket client here, and what the messages that he is writing to us. We have the same includes as every time in this series, for sake of simplicity. Here we define the port that we knew for the server, and also define the IP which we found to be true. This is our tag, UDP Socket client, and we are sending a message from the ESP UDP client. We expect our server to echo this message and to send it back. Okay, so let's see how it's working. First we connect the socket. This is the socket connection. Then we define some parameters for this socket, and socket is created. Let's see, socket is created here, and you have the IP and the port number. Then we go into the while loop and infinite loop when we're using send to. Send to is a command which is different for UDP and opposite to TCP. In addition to standard definitions like socket and the string payload, we also give the address, because UDP constantly sending information to the server in this case. And this which differentiate between TCP and UDP implementation. After it, we write the message was sent. Let's go back to our execution page. The message was sent, and then we receive bytes from our server IP with the message that we have sent, message from UDP client. The message was echoed back to us. Okay, that's about it. And to summarize, here we have seen the implementation of UDP client in the Wi-Fi medium by establishing a UDP socket between two ESP32 boards. And we've seen the example of sending message and echoing the same message back to the UDP client. Thank you.